Imagine this. You're not coasting into a roadside gas station, you're gliding toward a fueling post on the moon's cratered surface. Your spaceship is running low after a long burn from Earth. You dock with a robotic refinery bathed in sunlight, a hum of machinery pulling fuel from ice that's been frozen for billions of years. It sounds like pure sci-fi, but in 2025, it's edging into reality. And the name behind it? Starpath Robotics. A startup that wants to turn the moon into humanity's first true deep space pit stop. We're talking millions in funding, radical tech, a vision that could rewrite the rules of space travel, and all of it hinges on one simple but world-changing question. What if the moon wasn't a dead rock, but the beating heart of our space economy? The hidden gold rush. The moon's draw isn't just its proximity, about 240,000 miles away. A 3-day trip for a modern spacecraft. It's the buried treasure at its poles, water ice. Locked inside permanently shadowed craters, this resource is more valuable in space than gold. Water is life for astronauts, but for rockets, it's fuel. Through a process called electrolysis, water can be split into hydrogen and oxygen, the same propellant mix that powers giants like SpaceX Starship. This isn't new science. What's new is the possibility of making that fuel right on the moon instead of hauling it from Earth. Costs $10,000 plus per pound to launch. Do the math and the case is obvious. Producing fuel on the moon could slash costs by 90%. That turns missions to Mars, asteroids, and beyond from barely feasible to economically sensible. NASA proved water ice was there back in 2009 with the L-Cross mission. Since then, in situ resource utilization, ISRU, the art of using local space materials, has become the holy grail of space logistics. The Artemis program is laying groundwork for human crews to return to the moon. SpaceX is testing orbital refueling. Blue Origin is designing cargo landers. Meet Starpath. Founded in 2023, Starpath Robotics didn't enter the space race quietly. CEO Saurav Shroff has been pitching one radical idea to anyone who will listen. Build a robotic propellant mine and refinery on the moon. This isn't a one-machine trick. Starpath's system starts with autonomous mining robots, built tougher than Mars rovers. Crawling over the lunar South Pole. Using drills or microwave heaters, they'll melt and collect ice hidden beneath the regolith. Moon dirt. The water gets piped into a refinery, split into hydrogen and oxygen, and liquefied for rocket use. Shroff claims their technology is the world's most advanced for off-world mining, built to survive the moon's brutal extremes, temperatures from 250 degrees Fahrenheit to plus 250 degrees Fahrenheit, no atmosphere, constant radiation, and dust fine enough to shred moving parts. The payoff? Hundreds of tons of liquid oxygen per year, ready to feed rockets from the moon's surface or be lofted into orbit as a literal gas station in space. And the money is flowing. In August 2024, Starpath secured $12 million in seed funding to accelerate development. This year, they're running an end-to-end demo in Earth-based lunar simulators, giant vacuum chambers that mimic moon gravity, dust, and thermal extremes. If the demo works, the next step could be shipping the whole system on a commercial lander from iSpace or Astrobotic. Partnerships are rolling in too. In late 2024, Starpath teamed with Atomic 6 to design a lunar power tower, a solar farm to feed the refinery's massive energy appetite. How massive? Producing just 1 kilogram of oxygen on the moon takes around 24 kilowatt hours, the energy a fridge uses in a day. 2025, space race heat and Starpath's countdown. Right now, August 2025, the moon race is blazing hotter than ever. NASA's Commercial Lunar Payload Services, CLPS, has already sent rovers to hunt for water ice, with February's dual missions hitting polar targets rich in frozen reserves. MIT joined the action, sending 3 experimental payloads to test future base tech, from mining tools to resource processors. Starpath, meanwhile, is sprinting to finish fine-tuning its mining bots for Earth trials before year's end. Founder Shroff's bold aim: launch the first fully automated lunar gas station by the late 2020s. If their 2025 demos wow NASA, desperate for lunar fuel depots to make Mars missions economical, could sign on. But rivals are circling. China eyes a moon nuclear plant by 2035. Europe's ESA is prepping its Argonaut lander. and Japan's iSpace plans a June 2025 mining test. Starpath's edge? No humans, no life support. Just relentless robots grinding through the moon's unforgiving dust, turning a barren world into a working fuel hub. The challenges. If it sounds easy, it's not. The moon is an industrial nightmare wrapped in a romantic dream. Lunar dust is a villain in disguise. Razor-sharp, electrostatically charged, and desperate to cling to every surface it touches. Apollo astronauts called it the #1 hazard on the surface, capable of grinding down joints, scratching optics, and jamming vital machinery. Then there's the power problem. A single large-scale lunar refinery could demand gigawatts, far beyond today's solar capacity. Starpath's towering solar collectors may help, but a nuclear backup seems inevitable. And even if the tech works, the economics are a gamble. Who buys the fuel? Starpath is betting on NASA, private explorers, and even space tourism companies. Critics warn of environmental damage like ice depletion, while advocates insist extraction rates would be minuscule compared to reserves. Why this matters? Here's the big picture. If Starpath pulls this off, the moon won't just be a glowing rock in the night sky, it'll be the pit stop to the stars. Right now, every interplanetary trip hauls heavy fuel from Earth, draining efficiency and ballooning costs. A lunar fuel depot flips that logic on its head. Rockets could launch light, refuel in orbit or on the surface, and leap toward Mars, asteroid belts, or beyond without breaking the bank. Think faster, cheaper missions, permanent research bases, asteroid mining for rare metals, and even space tourism. Starpath isn't alone. Ethos Space Resources and researchers at 2M are already sketching lunar infrastructure, with moon-made oxygen in the works within a decade. As Schroff puts it, this is fueling the future of space travel with robots, transforming the moon into the ultimate cosmic service station. So, will Starpath's lunar fuel stations light the way? By year's end, we'll see if their Earth-based demos deliver. If they do, they won't just be proving a machine works. They'll be proving that space travel doesn't have to be chained to Earth's launch pads. From shadowed craters hiding billion-year-old ice, to orbiting depots ready for passing ships, the moon is shifting from a distant dream to a working hub. It's thrilling, it's real, and it's unfolding right now. Who knows, your grandkids might book a holiday cruise with a lunar stopover. Better start practicing your moon selfies. Buckle up, the stars are calling. If you found this video useful, please hit the bell icon to get more content. Leave a comment below with your thoughts, and thank you so much for watching.